Okay, programmer is not responding. It didn't work.
Run, rabbit, run, rabbit, run, run, run. Run, rabbit, run, rabbit, run, run, run.
Well, hello and welcome back to part 2 of the rabbit hole video. So a few questions have come up from part 1 of the video, and perhaps the most commonly asked question is, why has this rabbit got a huge strap on? And I really haven't got an answer to that, but I'm not sure if it's a rabbit or a pubic hair. And if you're wondering why it's called the rabbit hole video, it's because, you know, sometimes you start off those projects and you think, oh, it'll just take me 10 minutes, this is going to be easy. And then one thing quickly leads to another and you end up doing a lot more work than you actually needed to. Now, one of the reasons that I ended up going down this rabbit hole is, rather than paying the full $15 to get the proper device, I decided to be a bit of a Scrooge. So that has a Christmas theme, doesn't it? I was a bit of a Scrooge and just decided to buy some of these cheap OpenLog devices from Fleabay, and from a China seller. So unfortunately these devices have come without any software on them, so I've now got the fun of trying to load some software on them and get them to actually work. Okay, programmer is not responding. So okay, we've just tried to download the Arduino sketch and it didn't work. So the Arduino IDE it's trying to talk to the OpenLog device, and they've obviously got some rules established between the microcontroller on here and the Arduino IDE so that they can exchange information. But this OpenLog at the moment, it hasn't got any software on it at all. So what we actually need to install is something called a bootloader. Now, a bootloader can do lots of different things, but in this case what the bootloader is actually doing, it's allowing the Arduino IDE to actually speak to the microcontroller. We need to preload it with this bootloader. Now, the way in which you have to program the bootloader onto the 18 mega chip, it's different than just loading the main code onto the device that comes from the Arduino IDE Studio. What you actually have to do is, it uses different connections. You have to use something called in-circuit programming, and I'm back on the SparkFun website here. So in order to do this in-circuit programming, there's a particular set of connections that you've got to use, and those connections are just at the top of the board here. So just starting from the top at the left hand side, you've got a reset, then you've got something called SK, which is a serial clock, and then you've got something called MOSI, and then the final one is MISO. Now, you don't have to get too hung up by what these do. I mean, it's semi-interesting. So the one that's called the MOSI, which is the one from the end here, the MOSI pin, that stands for master out, slave in. And then you've got the MISO connection, which is master in and slave out. But we don't need to get hung out with what they are. Basically, they allow a programming tool to actually talk to the microcontroller here. They actually allow it to talk to the 18 mega and install the bootloader. Once we've got the bootloader up and running, the microcontroller will then talk quite happily to the Arduino IDE, but until we've got the bootloader installed, it won't do that. So the way that on the SparkFun website they recommend you install these the bootloader, they say you need something called pogo pins, or I should say, rather to do the in-circuit programming, you need something called pogo pins. Now, I don't know if you've heard of pogo pins. What they are is they're a way of making a connection to a board without soldering. They're often used for test points. So again, still on the SparkFun website, here's an example of a typical pogo pin. Now, there is different types of pogo pins. Some of them are designed to actually press against a pad, and they're like the male type, which is what this is. And you also have some female pogo pins, which kind of have like a socket, a cup on the end of them, and they're designed to interface with maybe a leg, you know, a component leg sticking out at the bottom of a circuit board where you've cropped it off and you've just left the leg exposed. But this is a male pin. So the way that these work is the tip here is spring loaded inside the brass column here, the brass part of the pogo pin. There's actually a spring, and that forces the plunger out, and it's got a little pointed end on, and the pointed end of the pogo stick will engage on the will engage on the pad on the SPI programming pads of the OpenLog. That would be relatively straightforward to do, wouldn't it? Well, you'd think it would be, but unfortunately the cheap and nasty Chinese OpenLog devices that I've bought, they don't actually have really proper pads on them. They haven't really exposed the SPI pins. What they've actually done is just brought some wires out. Now wires are a little bit like pads, but they're a lot smaller. So not only have we got now a very, very small pad to try and connect to, that pad is also covered in solder resist. So it's designed not to be soldered to. So yeah, cheers lads. Not only have you sold me a device which hasn't got any software in, you've pretty much made it impossible for me to program as well, so thumbs up. Well, I've got the microscope set out here, and I'm just trying to solder on some pieces of wire onto these wires, these little tiny pads that are on these OpenLog boards. So there's me just applying some flux with the tip of a needle, and I hope you can see the scale of this thing if you recognise that that was a needle tip. And this is also a needle point soldering iron that I'm using, and you can see I've already soldered some bits of wire on there. And again, those pieces of wire that I've soldered on there, just a single core of wire out of a multi-strand cable. I should say they're a single strand out of a multi-core cable, and even those under the microscope look quite big. So it does give you an idea of how tiny these pads are that I'm trying to solder to. Now, I did actually have a go at soldering some of these wires on, and to be honest, in the end I actually had to give up doing it this way because it was too much work. I didn't realise how much work it would be, and it's actually far easier to actually just to trace the tracks going back to the microcontroller, to the 3 to 8. It's easy just to trace the wires back and just solder directly onto the pins coming out of the microcontroller package. So although I did capture that under the microscope and I'm showing you it here, it really wasn't very easy to do. So now what I'm going to do is I'm going to attach those single strands of wire to a programming header, because once I've got this programming header, I'll then be able to plug in my the programming tool that I'm going to use. Well, you just saw me using the microscope there to connect the 4 in-circuit programming pins to our header connector that we're going to use here. And yeah, I've just got one to connect here. I've just got the last pin, and these pieces of wire really are quite small. They're just single strands of wire that I've pulled out of a multi-core, and I'm just going to solder this onto this header connector here, this single inline header, so I can actually plug in our in-circuit programming tool, and I'm going to use a bus pirate device to do the programming. Now, I don't know if any of you have seen the bus pirates before. Basically, it's just a little device which plugs into a USB connection on a computer, and you can do quite a lot of things with a bus pirate. It's kind of a bit of a hacking tool. You can use them to download software of various types using various different protocols. You can download, you can upload, you can do things like drive LCDs with them to test an LCD if you've got a new one. Basically, it just gives you a way of connecting a laptop computer to an embedded bit of a circuitry like this, and then running tools on your PC to actually to program it and work with it. It's it's easier than working in the embedded realm. So we're going to do that next. Now, you wouldn't necessarily have to use a bus pirate. My tool of choice would probably actually have been the one of the AVR programmers, but unfortunately the particular programmer that I choose to use, it's got a problem with compatibility. I typically use the AVR Studio when I'm working with Atmel chips, and there's a bit of a known bug between the Arduino IDE and some of the drivers which are used to run the USB in-circuit programmer if you choose to use something like AVR Studio. So unfortunately, although I have got a really nice AVR dedicated programmer, I can't actually run it on this laptop because there's a conflict with the drivers. So we're going to use a bus pirate instead, but yeah, there's a few different ways you could do it. Just for the record, don't ever ask to borrow my surface mount tweezers. You've got more chance of having a go on the wife than you have of borrowing these babies. Bus pirate.
Bus Pirate!
So here's our Bus Pirate device, and we're going to use this to do the in-circuit programming. I bought this one from SparkFun many years ago. I've not used it very often, but from what other people tell me, these are a fantastically useful bit of kit. You can use them to program microcontrollers from various different manufacturers. You can also use them as forms of serial interface, and you can also use them to connect to, you know, things like different types of sensors, because they will talk, you know, UART. You can program them to speak I2C, or we're going to use the SPI serial prefix interface bus on this. So, you know, you can connect different types of sensors to them. So if, for example, I don't know, you buy a humidity sensor, one of these little tiny humidity sensors, they quite often talk on an I2C bus. But you want to write the software on your computer, or you at least want to get the sensor up and running using a nice environment using your desktop computer rather than doing an embedded application. So what the Bus Pirate allows you to do, it allows you to plug in a USB cable to your computer, and then you can just use like Hyperterminal or something like that on your screen to actually send and receive commands. And the Bus Pirate will, for example, it will do the conversion between, I don't know, you kind of RS-232 stroke UART output. It'll do the conversion to like I2C or SPI or some other protocol. So they are handy. They're not a device I've used very much because they're very much in the command line style of things, where, you know, you have to type in these long commands, and I'm just not very good with command line stuff. I tend to get it confused. I'm pretty dyslexic, actually. Well, actually, my English teacher said I wasn't dyslexic. He said that rich kids are dyslexic, whereas I was just stupid. And yeah, he was probably right. Maybe I'm just stupid, but I struggle with long strings of characters and stuff like that, or even short strings for that matter. And that's generally the way that, you know, the software geeks use these. They drive everything using the command line interface. I don't like that. I much prefer to use an IDE. Hence, I haven't used it very much, but we are going to use it today. So it's got all these wires sticking out at one end, and I've just labelled these up to make it easier for myself. So what do we need to connect first? I think we need the reset line. Here it is, reset. So that goes there, reset. Then we need the serial data clock, which is a yellow one, which is going to go there. Now, the ones that I always get mixed up, we need Mozzie and we need Mizzo. So there's Mozzie. Where's Mizzo gone? Mizzo, where are you? Mizzo. Mizzo, right, okay. So the last pin is Mizzo. And then I've got that right. And then the one next to it in the middle there is Mizzo. Is Mizzy, sorry. Oh, Mozzie, God, Mizzy, Mozzo. Look it up, and the wire's falling off, hasn't it? Go on, get on. What's falling off? Was it reset? Something's falling off. Reset. Put that back on. Right, just because I've probably confused everything, we'll just go from left to right. So we've got reset, serial clock, Mozzie, and Mizzo. Do that one more time. Reset, serial clock, Mozzie, Mizzo. So we need to plug in the Bus Pirate now. So USB cable there, and then we will fire up the Arduino Studio. Quickly check our settings. COM3, Arduino Pro or Mini, which is what this thing looks like. We've got the right processor selected there. Yep, that's right, 16 megahertz, and it is the 328p. COM3. So let's just try and burn our bootloader. Let's press burn. There's something happening. Got some lights flashing on the Bus Pirate. Come on, have you worked? Are you doing anything? On the OpenLog there's actually a little blue LED which is lit as well, so yeah, I definitely think it is transferring some code into it. It's taking a little bit of a long time again though. Is it going to work? That's the question. Well, fingers crossed. I'm hoping that we have just managed to successfully program our bootloader into our 18 mega 328p. So that means that we should be able to now fire up the Arduino IDE again and actually download our sketch with the OpenLog software into it, and hopefully we should then have a working OpenLog device. So let's give that a go. Okay, so I've just actually disconnected the Bus Pirate programmer, and as you remember, that's an in-circuit programmer that was actually communicating with the 328P via the SPI serial peripheral interface bus. So what we've replaced it with now is just a standard, I'm going to call it a UART FTDI type device. God, I'm throwing in a lot of acronyms here, I do apologise. And the important thing about this, it's just basically works very much like a standard FTDI USB to serial interface, but it's got this extra pin brought out, which is DTR, data terminal ready. Now my understanding is what this actual purple wire does, it actually tells the bootloader, I think it causes the 328P to reset. So, and whenever the 328 sees that reset command, when the code restarts executing, the bootloader triggers, and then I think for a few seconds the bootloader then actively tries to connect to the Arduino IDE because it thinks it's going to receive some valid software. So I'm just going to plug in the USB cable, and that's going to power everything up. So you can see that the blue light, again, it's flashing on here now, and that's really the bootloader signalling that it's trying to connect to the Arduino IDE because it wants to receive some software. If it doesn't receive any software within, I think it's 3 or 4 seconds of this DTR pin resetting it, what it actually does, it then jumps to the main application code and starts to run that. But at the moment we haven't installed any application code, so that's the next job. We've now got to install the OpenLog software onto the 328P, so let's do that. Okay, so I'm back in the Arduino IDE and I've opened up the actual OpenLog sketch. So what I should be able to do now is I just need to check my settings, make sure the USB is on the right port. Yeah, it's detected it's on COM port 5, so hopefully that should all be okay. So I think all I need to do now is just press this button here to this little tab here to upload the sketch, and fingers crossed what it's actually going to do is it's now going to actually upload the OpenLog software to our Atmel 328P, and then it should actually start acting like an old OpenLog device and should be able to record some serial data. So let's have a go at that. Let's just press the program button, the upload button. So first thing it's got to do is compile the sketch, which it did before. It does seem to take a very long time to compile this. I don't know if all Arduinos take this long to compile, if it's just because my laptop, this laptop I'm using, is a bit rubbish actually. It's only very cheap and nasty. I tend to only buy cheap and nasty laptops for doing my electronic things because yeah, you know, you can have a habit of blowing them up, plugging something in you shouldn't do. So we've got some lights flashing now on the programming tool, so I'll take that as a positive sign. And I think the blue light is also flashing on the 328P on the OpenLog hardware as well. Okay, looks like it's finished. Oh no, I've got a green light, that's new. So we've got a green light flashing now on the OpenLog. So I think we're done. I think we've now we've managed to upload all the software that we need to on this OpenLog device, and it should now operate. So what we've got to do now is we've just got to take this little circuit board out of here, and we've got to plug it back into our RS232 to TTL converter, power it all up, and we should be able to well, we should be able to squirt some serial goodness all over its face. So let's have a go with that. Well, one little job I've still got to do is I've just got to remove these in-circuit programming leads that we're not using anymore. We don't need them, so yeah, just got to unsolder them. And I think I said earlier, I showed you a video of me trying to solder onto these little pads, and in the end I just gave up. I couldn't get the wires to stick, so I had to unfortunately solder them directly on top of the pins of the Atmel 328, which is not a perfect job, but certainly it's easier than trying to clean the solder resist off this board and then try and solder to the pads. So we just need to unsolder these. So we just need to plug in our God, yet another serial converter. I'm some kind of serial pervert, aren't I? All we ever seem to do is serial stuff these days. I don't even like serial data. Tell you what, next time we'll have to do something on Centronic's parallel ports. So I'm now going to press send from our terminal program. So on a count of 3, 1, 2, 3, send. And I don't know if you can see, we've got a light flashing there, and that means that it did receive some serial data. So it looks like we're working. So let's give that a go again. So I'm just going to press send again, and again, and again, and again. So the proof of the pudding now. We'll just turn the power off. Let's take this SD card out. We need to put this into our adapter and stick it in the laptop. So we'll just open up our SD card directory. Oops. And here's our, well, we've got 2 files being created. One of them is called config, and I think I did mention many moons away, maybe this video or the earlier one. The OpenLog device needs a configuration file, and if you don't put one on the SD card, it will actually create one. I've got to admit, I did cheat slightly, because I have been in here before, and I did just adjust the baud rate to 9600, because for some reason, by default, if you don't have a config file, it opens up as 34800 or something like that. So I did go in previously and I just put this config file on. But the file we want is this one here called log 0003. So let's open that up and see what it says. Up, and there you go. So happy Christmas and a happy new year from all the gear, no idea. And you know, I think that'll do. Thanks everybody. I hope you all have a wonderful Christmas and enjoy the rest. Bye for now.